Hey, good morning guys. Tyler here from Flex CNC. And today what we have for today is a quick machine demonstration of the Flex CNC G Series featuring our channel partners from Southern States Machinery. I have my guests Marco and Bill who will be joining us here in a second. And the focus of the demonstration today is to introduce the machine and show you how Flex CNC and Southern States Machinery are pioneering the way that job shops and fabricators are milling and drilling, tapping large and cumbersome parts that you can't fit in your traditional enclosed CNC machines. So, Bill, can you hear me okay?
I can, Tyler. Good morning.
Hey, good morning. Thank you again for joining us. So I'm going to go ahead and pass it over to our partners, Bill Plord, President of Southern States Machinery, just to do a quick introduction of the partnership and introduce your company. Bill, go ahead, sir.
Well, thank you. Good morning, everyone. My name is Bill Plord, Southern States Machinery. We are a provider of metal fabrication equipment from Virginia through Florida. And we've been in business about 20 years. We sell, we service, we provide applications as well. We're very excited to be partnering with Flex CNC on this machine. We've been partners with these guys for a few years now. And I think what they're going to show you is a very flexible machine that you're going to be able to mill and drill parts that the average job shop and fabricator can't even think about doing. They're either going to outsource or they're going to have to pass on the opportunity. So really looking forward to having them show what's possible. We also have one of these machines in our showroom in Mooresville, North Carolina, and we'd love to show anyone there for a live demonstration. But Tyler, thank you for doing this, and we look forward to having some fun.
Our pleasure, Bill. Thank you. So what do you say we go ahead and get this thing kicked off? So I'm going to do a quick machine introduction. So as you can see, the machine behind me is our Gantry series machine. It's got a 20-foot long by 4-foot wide machine envelope. As you can see down here on the machine, it's going to travel on a helical rack and pinion on the X-axis. On the Y and Z, we have high precision ball screws where the machine will maneuver around the fixed bed. So this machine is capable of holding parts up to 604 pounds per square foot. Having this fixed bed gives us the capability to hold heavy and long parts. Again, that traditional VMCs, where the beds that move can't necessarily accommodate parts like this. So the gantry stands about 23 inches above the machining bed. So if you do have some kind of like I-beam where you're going to be machining up to 25 or 30 inches tall, that's not an issue. We actually have the capability to raise the gantry here. We'll go ahead and throw a double rack and pinion to build rigidity in the machine. But again, the end user that we're going after is the job shop and fabricator who run into limitations on machining large and cumbersome parts in a single setup. So then the first demonstration that we're going to run for you guys is what we like to call pendulum mode. What pendulum mode is it allows your operator to stay productive while the machine is milling and drilling on one side. So as you can see here, the operator can continue to load and offload parts or inspect parts while the gantry is at the other end of the bed, continuing to make chips. Another benefit of this is that you get one table, but essentially you can break this 20-foot long bed up into several different work cells and keeping that spindle making chips, making parts, and loading and offloading the next part as they come in. Can we go ahead and get a shot inside in the machine? Okay.
Hey Tyler, while those parts run, I'll go ahead and kind of talk about what we're doing here.
Yeah.
So this is one of our standard hex blocks that we run. There you get a good look of it there. While Tyler was talking, the first drill that ran was a 27/64 Mega Muscle drill that is from OSG that I use to pre-drill out the corners of the slots and then to pre-drill this center hole here. That way when I mill out this bore, I've got somewhere for the chips to go. What's running right now is our 1/2-inch Harvey end mill. I'm taking about 100,000 step over. We're running at 3,900 RPM at 39.5 inches per minute. And I programmed this part up in Mastercam, and the toolpath that I used was a 2D high-speed dynamic toolpath. So what that allows the machine to do is, as it's going around the part, it's going to take the shortest distance to get to the next section of the part that needs to be machined. And that's what it's doing right now. Isaac, if real quick, can you pull up the controller? We'll get it here in a second. So as we're waiting on that, Marco, I know you had a couple stories that you wanted to talk about with some of your customers right now. So I'll let you go ahead and talk about that while this part's still running.
Sure. Hello, everybody. This is Marco Salgado, a sales engineer with Southern States Machinery. I cover Central and South Florida. As many of the people watching this hopefully know, that we cover the whole eastern border of the United States. Hopefully some of my Florida customers are online and watching this video. I feel I'm getting my 15 minutes of fame here. It's my first time on YouTube. So anyway, I just wanted to get into and talk about, I've been able to sell a couple of these machines in Florida. We have a couple of different applications out there, and I just wanted to talk to you a little bit about what those are. Probably one of the first machines that was installed here in Florida is at a packaging manufacturer on the West Coast, and they drill thousands and thousands, drill and tap thousands and thousands of holes into tubes and other geometries for what they do, for their product. And they were doing this with smaller knee mills and smaller machining centers, and it was requiring a ton of setup, process a small area, set up again, process another small area, set up again, process another small area. So they would, every time you set up, one time, another time, a third time, a fourth time, a fifth time, you're losing accuracy in your part. You're depending on whether that part gets set up correctly every time, and another one processing, then the accuracy that machine is giving you is not there anymore. So, like, okay, so that's for them. I've actually brought other customers there to see their facility and get their feedback as well. And that's a facility that we could visit at some point if someone is interested in one of these machines. Another customer has a bit of a unique application where they make it's kind of like 3 foot by 3 foot frame in 1-inch tube. Okay, and these different parts of 1-inch tube get welded together and make a square frame, and then the welding needs to be milled down, grinded down, milled down, so that you have a truly flat surface, because there's some other stuff that gets mounted on this frame. They were doing that manually. And then there's some holes that need to be drilled and tapped as well. So there was a lot of work that went into each part, and these are thousands and thousands and thousands of these parts a year. So they got a 6 foot by 15 foot machine, and they're able to do multiple setups and do the pendulum mode that you guys are showing. And so while it's processing on one part, they're removing the finished part and loading another part that's going to be done. And they're milling, once again, they're milling the excess welds, and they're drilling and tapping the holes all in one setting. Okay. And then another customer that we have bought a 4 foot by 20 foot machine. They are a job shop. They do a lot of different work. They had large parts that they were going to mill, and you guys are going to show a view soon where you show a large part kind of hanging out of a traditional machining center. And that's exactly what these guys were doing. You take that plate off the end of that machining center, you stick that big tube in there, that big part in there, you process what you can, you move it, you do that again, you move it, you do that again, and you're taking up a big space of floor space, but you're only milling a small space at a time. So that's what they bought it for. They're still working, adding a different plate setup on the base of it so they can get real creative with their clamping. So it's been, my experience with it has been really good. This really fits a niche that is out there. There's a lot of large part machining or production machining that would be done better if you can do in pendulum mode and you keep the spindle spinning at all times. And a traditional machining center in that size is very expensive. The price point of this machine fits right. The capabilities fit right. There's a lot of options you're going to show, including that fourth rotary axis. And I think it's been very successful, and I think the future is very bright with this machine moving forward.
Awesome, thank you, Marco. Hey, Aaron, how are we coming along with that on that cycle?
Yeah, so right now we're taking some finish passes on this part, and the pendulum mode that Marco was just talking about, I'll showcase it here as soon as this machine is done with this part, and we're gonna travel down on the bed to machine another part. And the key is the light curtains on this machine. We can move them wherever we need to, so your operator can stay behind the light curtain. And I'll be able to showcase that here in just a second. We got about one more finish pass on this part, and we'll get working on the other part.
Awesome.
Hey guys, can I say one more thing?
Absolutely.
That view you're showing right now, I think is really good, and I like that because you can see if you move back a little bit where you have that part kind of fixtured at the end of the table. What I want to say is, you know, when you have a large
They
bed,
want to see the trunnion.
yeah, show more of like the different areas of the bed. When you have seen such a large working area, not only can you do a part that comes along, you know, once a month or once a quarter. It's not something you're doing every week, but there is consistent throughput. It's just not being done every day. And with a large bed, you could leave the fixturing for that part if you have enough space on your bed. If you can buy a bigger bed, that's always great. But if you know that part is coming again in a couple weeks, you don't want to go through the trouble of taking down the clamping and then resetting it up because there's a lot of work to do that. Well, with a large bed, you could leave a clamp setup on the end of the bed and just don't take it down. You know, wait till, next month or a couple weeks down the road when you have to do that part again, and it's sitting there, it's all set up. You just got to put your blank in and machine it. So that's another benefit that, you know, my customers have seen with a large bed like this, and I just wanted to point it out because one of those views you guys had, and we're looking at it here a little bit as well, showed that, and you have so many different setups that you have at a time, and you're not having to break down a clamping setup every time you're going to do a different part. So I think that's key as well.
Yeah, Marco, you definitely hit some great topics and features of utilizing the pendulum mode. And just to kind of piggyback off what you were saying, as you can see with this 20-foot long bed, you essentially have one table or one machine with two tables. So utilizing those 8 and 9 foot long parts, you essentially are getting 2 machining centers in one. So you did hit on a great point too. Having the capability to set up different jobs on this machine. So we got the 2 Kurt vices here in the front, the 11-foot tube in the back. That way you can leave your fixturing as is. So we got the Kurt vices here in the front, we got the 4th axis on the back part of the machine. That way, if you're one of those job shops or just a fabricator doing all sorts of different parts like pipe, tube, plate, beam, and bar, this machine gives you the capability to machine those parts and leave those fixtures set up just as Marco said. So Aaron, can we go ahead and talk a little bit more about, now that the machine's in the other cycle, the use of the light curtain?
Yeah, absolutely. So here we just finished this part down here on the left. So what I'm capable of doing is taking this light curtain, and while the machine is still running that part over there, I can move this light curtain down. That way I'm between, or the light curtain is between the machine and myself. That way I'm protected as an operator, and I can come in here and go about changing out my part while the machine is still running the other part. And that's really key on keeping your spindle up the entire time. And just like Marco was saying, you know, it doesn't even have to be with having multiple setups on the machine. Running your parts in pendulum mode doesn't even have to be the same part. You could have, while you're changing out a part that was just finished, you could be running a completely different part in a different setup on the other side of the machine bed. But if you got a large quantity that you got to run through, this allows you to keep your machine loaded up. And as soon as I'm finished changing out my part, all I got to do is just move the light curtain back. And as soon as we're done with the cycle down, the second part that we're running, the machine can travel right back down and start on the first setup.
Awesome, Aaron. Yeah, thanks for showing that demonstration for us. So as you can see on the front of the machine, you do have the sliding light curtains. A lot of our customers are placing this machine against a wall in their facility. However, if you do need to place it more in an open environment, please do keep in mind that there are light curtains that you can actually put on the back side of the machine. That way you have the capability to load and offload parts, especially if you get a wider gantry. So if you have an 8-foot or 10-foot wide gantry, you might need to access both sides of the machining center to safely load and unload the parts. So again, here in our shop, we got ours posted up next to the wall. But there are additional light curtains on there that we can add to keep those operators safe when loading and offloading parts onto the Flex CNC Machining Center. Hey Isaac, when you get a second, can you see if we've had any questions come through on the live stream? Hey Aaron, now moving on in the demonstration, can you tell a little bit more about the benefits of the external linear control panel? Maybe talk a little bit more about the pendant as well as the control of the machine.
Yeah, so Isaac's gonna pull up the control screen right now. And what you're looking at, this is our 1/2-inch end mill that's running with that dynamic tool path that I was talking about. And what you're looking at on the screen, the line that is currently being executed is highlighted in red. And if you can see just below that on the left side of the program, you see a red line that kind of shoots out in front of that line that is highlighted, and that's our infinite look ahead. So that's what allows this machine to run that dynamic tool path because it's always reading the next line ahead. It knows what the machine's gonna do before it even gets to that point. And I can't show it right now because we're in automatic mode, but as far as the ease of this controller, what we do in our training class is I'm the one who hosts our training class. We go over everything on this control as far as the main page, the editor page, you know, the auto tab, MDI manual. So you know, it sounds like a lot as far as you know, the amount of things that need to be learned, but the control makes it super easy for the operator to learn, to use. Loading and unloading programs, everything like that. And then like Tyler mentioned with the pendant, which comes in handy a lot for setup purposes. I don't know, Tiffany, if you can zoom in on that a little bit. So what the pendant allows the operator to do is control the machine manually. They can, you know, jog the X-axis, Y-axis, Z-axis. And what that does is it takes the manual tab off of the main screen on the controller, and everything is being used by the pendant with the dead man switch here. Once again, for setup purposes, you know, when you get into dealing with a 4-foot or a 6-foot wide bed, your setups can get kind of tricky, and having the pendant on the machine comes in real handy with setup.
Thank you, Aaron. So yeah, I just wanted to piggyback off what Aaron just described previously. So as you can see, our external linear control panel, this allows for the operator to take the control up and down the length of the machine. So we do have some customers out in the field with 35-foot long, 45-foot long, and 50-foot long machining beds. And the nice thing about the the linear control panel is that you can actually take the screen up and down the length of the bed. So if you're working on a job on the far end, while the machine's down at the other end setting up, it gives you that flexibility. That way you don't have to walk up and down, the length of the bed. So you can do all your programming right here at the machine.
So Tyler, it looks like we got a pretty good question up there. Craig asked, how many different setups can you put on one machine and how would you fixture it? And I can touch base on that because I know we've dealt with a lot of customers who are running all kinds of different sizes, shapes, and just on what we have set up here on the machine right now, the demo block that we're running right now is just in your standard Kurt vise, but we also have pneumatic vices in the back set up for a long part that are very good for your drilling and tapping applications. They are, we're gonna do some light milling on it as well. I know you saw the fourth axis up there that's kind of static sitting up on the table right now. But as you, depending on the length of your part, the length of your machine, you can fit all kinds of different setups on this machine bed. And going back to the control with having different setups, once that setup is there and you create your work offset for that part, that setup can stay there. If it's out of the way, that work offset can be saved. You could come back 2-3 weeks later, run the same part off of the same work offset. And here in a second, we'll show you the cart top that we have sitting up here on the pneumatic vices. And but yeah, to answer your question, Craig, there's really an unlimited amount of options. It's all based off of what the customer's running, how big the part is, and so on.
Hey, question for you guys, Marco here.
Yeah.
Can you give a little bit of information about, and I don't know if you're planning to do this a little bit later in the demo or not, but can you give a little bit of information for everyone on programming? How you would go about doing that. Of course, we sell this to a lot of job shops that aren't traditionally in the machining world, so that question comes up often.
Yeah, that's a great point. I'm going to go ahead and toss that over to Aaron to tell a little bit more how this machine's still a great fit for the fabricator who may not be familiar with G&M code.
Yeah, so like I mentioned earlier with these parts, I had programmed them off of Mastercam. So if customers are using a CAM software, every CAM software is different, but they're essentially doing the same operations. So I can kind of help the customer through that training that I talked about on what kind of operations they're going to be doing and what that G code is going to look like. For any of those customers who don't have that experience, which I actually had a phone call yesterday with a customer who was kind of concerned about that. And what I try to help with in that training class is gear that training class specifically for that customer and what they're going to be doing. So if they're just doing some simple hole drilling, tapping, everything is done off of G&M code. But each operation, there's really only, let's say, 2 or 3 G&M codes that are related to that operation that the customer is going to be doing. So as while they're here for training, those are the G&M codes that I really try to make sure that they understand. They understand how to, if they need to type the program up themselves, they understand how that program should look like, what each line should look like. So like I said, for the customers who don't have a whole lot of experience, what we try to do is make sure that the G&M codes that they will be using while they're here with us for the training, that they understand how to use them and can make their own programs.
Well, and what are some names of some software that you guys know that some of your customers are using?
So we have Mastercam, which is one that we use. Fusion 360 is a very popular one. It's very easy to use. It's more on the cheaper side. There's Gibbs Cam. I believe Autodesk has their own CAM software built into their AutoCAD program. Those are just a few that I've heard other customers using. But as far as the CAM softwares, there's numerous different CAM softwares out there.
Okay, good. Yeah, in the sheet metal fabrication world, you bring in a drawing or a model into a software, you process it to a machine, you know, during the programming, you might tweak a couple things, and then you send it to that machine. This is essentially, you know, fundamentally this sort of the same process. Is that correct?
Yeah, exactly. And the nice thing about this controller, it's very comparable to the FANUC controller, which is a very popular controller in the CNC world. And we're in the process of finishing up having our own posts that we can give to the customers. But just to kind of show ease of use on this controller, the parts that we're running right now, we have other Haas machines here in-house. So when I programmed these parts on Mastercam, I actually posted the program with our Haas post, and it just modified it a little bit to fit our machine. And the reason why I say modified is our machine has a variable pump coolant system. So your standard M code for coolant, for flood coolant, is M8. With having the variable pump for our coolant pressure, the only thing I need to add to it is how much pressure do I want that coolant coming out with. You know, we use an M8.1 all the way up to M8.4. So those minor modifications are the only thing that I've needed to do. And like I said, we're finishing up creating our own Flex CNC post that we can give to customers that they can use to implement in whatever CAM software that they are using.
Great question, Marco. Yeah, thanks for bringing that up. And Aaron, thank you for addressing that nicely. So that's going to conclude the first part of the machine demonstration where we covered pendulum mode here. So now that we got our two finished pieces here, what we're going to jump into is the phase 2 of the demonstration, where we got a square tube loaded on the back part of the machine. It's fixtured down with 4 or 5 of our pneumatic vices. And we're going to be running just some simple drilling, milling, and chamfering operations just to showcase the flexibility of the machine and show how this machine truly is designed to machine long and cumbersome parts here. So, Aaron, what do you say we go ahead and get ready and we'll run this cycle on the 11-foot tube?
Yeah, absolutely. And Marco, I know you touched base on it, and I know Isaac had shown video before we went live on you're talking about the parts sticking out of the ends of the machine. You know, having this long part fixtured in one location, we don't need to do any part manipulation on the piece, and we can get everything done in one shot. You know, this is going to be a great kind of showcase for that.
Hey guys, if I could interrupt 1 second, this is Bill Plord. I mean, this picture is worth $1 million. That shows what our customers are trying to do. They're repositioning, they're trying to do longer parts, and this machine just takes all that away from them with multiple setups. It's just so flexible. I mean, that's a great shot.
Thank you, Bill.
So here I'm using a carbide inserted drill. It's a 571 diameter. We're just going to drill some smaller holes and then bring that 1/2-inch Harvey ML back out, and we'll mill some slots. I know a lot of our fabricator customers that we've had before, you know, essentially that's the majority of what they're doing. They're drilling holes, they're making slots. So we just wanted to showcase a little bit of that here on this long part.
So yeah, as you seen in the video, our typical enclosed CNC machining center, and I'm going to piggyback a little bit off what Bill said, anytime you have to refixture a part definitely is a waste of time. Secondly, you run into the risk of losing your tolerances on the part. So having the capability of nesting several different parts up onto the fixed bed gives you the capability to not only run more parts, but if you get a machine long enough, again, breaking that machine down into separate work cells, that way you can nest batch A on one side, let the cycle run. While that's running, you're on the other side, loading and offloading, inspecting parts. That way your operator is constantly staying busy, the machine's always running, leading you to manufacturing parts quicker, reducing your costs, and increasing the flexibility in your machine shop.
Hey, by the way, can you guys hear me?
Yeah.
While you're on that view, in the background, we can see your nice facility. I just want to point out that you guys have put together a great facility for assembling this equipment. This equipment is assembled and supported right here in the United States. And that's a big deal. You know, when you need some help with something with the equipment, whether it's, we have the FlexCam program for helping with programming, but when there's, you know, a part that needs to be replaced or something needs to be adjusted, the knowledge and the support is right here in the US, and I think that's huge.
Thank you, Marco. Oh, looks like we got a question, Isaac. Let's see. What is the tool changer capacity, spindle RPM, and spindle taper? Awesome question, Doug. Thanks for reaching out to us today. With this machine that you see here, with the Cat 50 spindle, we're going to have a 10-station automatic tool changer. However, if you would like to have more tools in your carousel, there are options to increase up to 20 tools with the Cat 50. This machine is also available in a Cat 40, so depending on your current tooling that you have in-house, that option is available for either a Cat 40, Cat 50, or also the BT as well. This machine right here has a 4,000 RPM spindle, so we're generating up to 368 foot-pounds of torque. So this machine also comes equipped with a gearbox. What that gearbox is going to do for us is allow us to push our tools quicker, make larger holes in the material. Other options that we do offer, if you're looking for more of a milling machine, we do offer a 12K spindle, a 6K, and the 4,000 RPM spindle. Thanks, Doug, for reaching out.
Hey, you guys, a question for you. I had a question come in over here. But I believe later on are you gonna get into the 4-axis specifically at some point, or should I just ask that now?
Yeah, I mean, if you'd like to address the question now, Marco, we can definitely dive in for you.
All right, cool. Let's just talk about the 4-axis. The question is, what is the max size for the 4-axis? I guess what's the max size of part you can process with that? I've seen a video of a customer of yours up north where you guys are doing a big, is what seemed to be like a more than a foot diameter tube that you guys are processing on it. But can you get into some of the specs on the 4-axis? Also, when you get into the 4-axis, it's real key your in-house capabilities for creative clamping. Can you get into that as well?
Yeah, absolutely, Marco. Thank you for bringing that to the surface for us. So just to answer your first question here, our standard 4-axis, it's a 10-inch platter. You can get either a 3 or 4 jaw chuck. So our 4-axis actually is an indexer. So what I mean by that is you can index the part, do your operations, whether that's milling or drilling, and then index the part and continue your operations that way. So again, our standard 4-axis is about a 10-inch platter. And we also have customers where we can offer up to a 16-inch platter. So the video that you were talking about, Marco, that was one of our great customers up in Wisconsin. So they were actually comparing us to a tube laser, but they ran into a limitation on the size of tubes that they were working on. So they were milling and milling and drilling some 16-inch diameter tube, and they ran into that limitation. They reached out to Flex CNC, and we were able to accommodate. So whether the diameter of your tube is 2 or 3 inches, or even up to 15 or 16 inches, we'll be able to accommodate a 4-axis to work well with your part. And then secondly, like I mentioned earlier in the video, we do have the capability to accommodate taller parts. So if you do have like a 16-inch tube that you'd like to run, we have several customers out in the US who have raised their gantry up. So when we do that, we'll go ahead and throw double guides and racks on the machine. That way we're not going to lose any machine rigidity. So we do have a couple of customers out there in the field where we've done that, or with our C-Series, we've actually lowered the machine bed to accommodate those taller parts. Now when it comes more into the fixturing of the tube, we're going to jump in and talk more about the pneumatic clamps here after this demonstration. So Marco, go ahead and we can talk about that here in a little bit, and we'll talk more about the variation and the customization fixturing solutions. That way, when we go ahead and deliver a machine, it's completely turnkey. The day the machine's installed, it's ready to go.
So before we get into showcasing those pneumatic vices and the other clamping options that we can help out with, this part is finishing up right now. And so like I said before, we drilled some holes and made some slots. I know Isaac's got some footage of what that finished part looks like. There you go. And so we drilled some holes, made some slots, and then I brought in a chamfer mill after everything was completed to chamfer the top of the holes and the top of the slot.
Awesome, awesome. All right. Yeah, and then proceeding on with the machine demonstration. So we want to talk a little bit. We want to circle back to Marco's question about fixturing. So just to start off, as you can see in your view right now, this machine has T-slots which run the length of the bed, and there's multiple different fixturing options. Some common ones are using simple manual Kurt vices. Again, we're going to show you the pneumatic vices, the 4th axis indexer. And Aaron, are there any other fixturing methods that I might be missing out on, maybe like for plate or anything else you want to touch on?
Yeah, so the cart top actually that we have right here on the machine in these pneumatic vices, this thing is loaded up with just a bunch of 1/2-13 tapped holes, and a lot of solutions that I've tried to help with customers if they got a big part that doesn't, a standard Kurt vise isn't big enough. So how can they go about holding onto their part? And if you were to line this machine up with fixture plates, similar to this, that gives you the capability of throwing a clamp essentially anywhere you need to, no matter how big or small that part is. They can put locating pins on this to locate the parts consistently. And something else with the pneumatic vices is the multi-insert that we can put into the pneumatic vise. And what that allows the customer to do, let's say they're running some 2-inch square tubing and they're just poking a bunch of holes down the entire part, they can actually load up, let's say 4 or 5 of those tubes within that one pneumatic vise, and they can clamp on them all at the same time.
Awesome, yeah, thanks Aaron. And then the one other thing I wanted to touch on too is, so these pneumatic clamps, they're actually pneumatically plumbed when they come with the machine. Can you go ahead and just give a quick example on how those open and close for us?
Yeah, sure. So you can see we've got 3 pneumatic vices here, and what's kind of hard to see is the toggle switch that's up underneath. Right now they're closed, so all it is a matter of just flipping that toggle switch to open up the vise. And here we've got our arm here that I can swing over to the part. Bring the magnet down on top of the part.
So the lifting mechanism that Aaron's displaying for you is one of our flex arm part manipulators that we manufacture here in Ohio. So this setup right here is perfect for pick and place applications. So it's going to turn a 2-man operation into a 1-man operation. The plate that is loading and offloading on the machine are actually our mobile carts that we sell with our pneumatic tapping arms. So we actually do use our flex arm manipulator to quickly, safely, and easily load and unload heavier, cumbersome parts, again, a 1-man operation onto and off of the machining center.
Hey, Tyler.
Yes, Bill.
Hey, I just wanted to mention, because we did see the backdrop of all the flex arm signs, and for anyone who doesn't know who Flex CNC is, they certainly have heard of Flex Arm. You guys have been around for years and years, and just wanted to make sure they were aware of the correlation.
Yeah, absolutely, and thank you for bringing that up, Bill. So yeah, just a quick background. I mean, FlexArm, we're the industry leader in the U.S. for pneumatic and hydraulic tapping arms, and this is a machine that we are now offering as well with our channel partners there, Southern States and Bill's team down there. But yeah, same manufacturer located here, headquarters, Walpole, Connecticut, Ohio. Thank you.
Hey, Tyler, something else I wanted to mention. Oh, sorry, go ahead, Marco.
Go ahead, Marco.
Couple questions here. First question I've got is, can you blind tap stainless? Okay, hold on to that one. And then, okay, 3-inch by 10-inch tube. I have a customer down in South Florida. I want to say hey to my buddy Jeff. It's a 3-inch by 10-inch tube. They're really long, and Jeff can tell me how long they are again because I don't remember. But they cut some holes into it, but then also at the end of it, at the end of this, they're used on scissor lifts, big scissor lifts, and at the end you have to cut kind of a tapered shape into it. And I'm sure they do some other processing to that part. So, you know, Jeff just wanted me to kind of ask about that. Once he can tell me what the length of them are again, we can kind of talk about what size machine. And then at that point, with them being that big and them being rectangular, I don't know, and you guys would be able to tell me if you're going to process multiple sides, but with a big 10-inch by 3-inch tube, I don't think you're going to put that on the fourth axis for it to rotate, right? You would probably just process one side, manually rotate and process the other side, but you guys can tell me better. The length of the tube, by the way, is 20 foot to 40 foot, okay? So 10 by 3-inch rectangular tube, 20 to 40 feet long. And then the blind tap on stainless question.
Yeah, so I'll start with the blind tap on the stainless. You know, as long as the customer is using the right tooling, the right tap, these machines do come with a rigid tapping option, so they can control the depth of that tap. And as far as the material goes, a lot of that is just making sure they're using the right tooling. Size of the tap can play into that, but yeah, I don't see any issue with the stainless tapping. As far as the big part, no, I would probably not suggest fixturing that on the fourth axis. You're going to get into more complicated situations with needing to rotate that and having the clearance to do it. So what I would suggest is to have Jeff send you the print. We can kind of talk about it, but there's possibility for maybe a 90-degree head application, or once we get a better look at it, I might have a better idea of exactly what you're talking about. But obviously these machines are customizable, so the length isn't an issue. The width isn't going to be an issue. I think it's just going to come down to more or less programming and tooling in that regard.
Okay. Thank you.
Yeah, great question there, Marco. And then let's see, it looks like we had a question pop up there. Do you have a beam line as well? Mark Williamson. Hey, Mark, how you doing, man? Yeah, so actually, we'll go ahead and get you some quick footage of the new beam line that we're going to be introducing to the market here soon. So it's a 40-foot long beam processing machine, again, designed for the fabricator who is still using older technology like mag drills and using their tape measure and marking out their parts. So as you can see here, we got a 40-foot machine here, still finishing up a couple touches in the assembly process, but hoping within the next month or two that we'll be having some I-beams on this machine. We'll be making some chips and getting you guys some more information and demonstration on this machine. So we're super excited about this machine also, and more videos, more footage and information on the FlexBeam coming soon.
Hey, did you guys already explain what you have on that fixture you have on the fourth axis?
Yeah, we can go ahead and jump into that. If Tiffany, would you like to get the camera over here where the fourth axis is? And we can kind of piggyback off too, Marco, on the different kind of custom fixtures that we have done too. So the pneumatic vices that Aaron has shown you earlier, those have a clamping distance. They'll accommodate parts up to about 24 inches. And then there's a pull pin where you can accommodate every 2 inches, and it has about 2 inches of stroke to accommodate different kinds of parts. We have made larger pneumatic vices. That way we can hold 4 foot, 5 foot, 6 foot plate, depending on what the customer's looking into. And then as you'll see, the 4th axis set up on the CNC machine. Aaron, would you like to talk a little bit more about this setup?
Yeah, so this is a trunnion that's set up on the 4th axis. What it gives the customer the ability to do is load up multiple parts across each side of this trunnion. And there's all kinds of different trunnions out there that we can incorporate onto the 4th axis, but it gives the customer the ability to machine multiple faces of their parts all in one setup. So essentially the goal is to load up a bunch of parts and run finished parts all in the same cycle. And kind of going back to the pneumatic vices with the 4th axis, we have vices that are essentially V-blocks that can clamp on multiple diameters if they're wanting to run some pipe through the 4th axis, and that the pneumatic vices that they're using can be controlled by the program itself. We can run off of an M code, or that when it's ready for a rotation, the vices will automatically unclamp, and the 4th axis will index to the right degree that's in the program. And then once that rotation is completed, the vices will automatically clamp back up as well. So I know that's going back to part manipulation. If they're running pipe that is long, you need a bunch of support across the bed of the machine. We can plumb up all those pneumatic vices to work directly with the program and the part that they're running.
Awesome. Yeah, definitely help reduce chatter on those longer parts. So yeah, great point there too. But yeah, with the 4th axis, again, 10-inch platter here. There are different sizes that we can accommodate based off the size of your part. The best way for us to diagnose a solution or prescribe a solution for you, just like Aaron mentioned earlier, if you have step files or if you have prints, we'll work together and we'll get with our partners over at Southern States Machinery and help guide you to what solution may suit your guys' shop best. So without any, Marco, before we sign off, is there any other questions that we can wrap up for you, or would you like to make any last final comments?
No, we've answered the questions I've gotten over here. Great presentation. I know there's stuff that we still haven't touched on, and we'll touch on a future a demo as well. But hopefully, it was helpful to everybody that was watching.
Awesome. Hey, we appreciate you and Bill joining us today. Aaron, thanks again for your help with the CNC. So, hey guys, stay tuned. Hopefully, in the next month or so, we'll have a new video out for you. Don't forget to hit like, subscribe on our Facebook, Instagram pages. Go ahead and like your guys over at Southern States Machinery. And again, thanks for reaching out. Bill, do you have any final comments?
No, I'd just like to thank everyone for joining in. And if there was anybody listening from north of Virginia, our sister partners, Mid-Atlantic Machinery and Northeast Machinery Sales, can help you from north of Virginia all the way to Maine.
Excellent. Well, hey guys, again, we appreciate your time today, and stay tuned. Hopefully in the next month or two, we'll be running something new for you. So enjoy the rest of your day. Thanks for tuning in, guys. Take care.
Thank you.